So we'll start from this problem. So this problem is called as a single limiting factor problem. So what is a limiting factor is, we normally assume a company has like enough raw materials, enough labor, enough electricity, and enough other kind of resources. But sometimes these inputs, okay, these raw material, labor, or machine hours or labor hours might not be available all the time. So sometimes what happens is one of them might become a constraint. Okay, we will not be like, we can't get a lot of a particular input alone. Okay, for raw materials might be in short supply, or labor might not be available as per our requirement. So what happens is we cannot produce all the products which we thought. So we have to only produce a limited number of products. So assume when you have like multiple products, then you have a choice of producing the product which is like the most profitable. Okay, normally we produce the most profitable product, but in marginal costing it tells it's not only like the most profitable product, it's about the most profitable per limiting factor. Okay, limiting factor is the is the resource which is like not available a lot. Okay, so we have to find out which one is profitable in terms of the shortage. Okay, so that product is what we have to produce. So we'll first go through this problem and we'll get a idea. So this problem is usually similar to the overhead absorption problems. Okay, so if you have a good idea about overhead absorption problem, these are quite easier. Even if you are not aware about overheads problem, still we can do this. So we have to first set up a table. So the table would be like, so there are three products here, and we have okay, we have selling price and variable cost. See, we have to find out the contribution, because in marginal costing contribution is the most important number. So first we'll find out that. So contribution is selling price minus variable cost. We'll go to the next number. See, the next number is, we have to find out, okay, we have to find out what is the total, okay, machine hours. He says that the maximum machine hour available is 1400. So that is going to be the limiting factor. So limiting factor in this problem is the machine hour. So that he itself has given. We don't need to find it out. And we need to find out how many machine hours each product take. Okay, so machine hour per unit, so that we want. So to find out that, first we need to find out what's a fixed production cost. Why do we need that? We'll first enter it and I'll explain. See, fixed production cost incurs because of the machine cost. That's what he says. Fixed production costs are being absorbed for a machine hour of 2 per machine hour. So for using the machine, the company has to pay, okay, around some $2. We can assume like that, $2. So machine hour rate, see, rate is $2. Okay, so it's always 2. Now the company has paid $10 for using the machine, and for every hour it is $2 they have to pay. So how many hours they are using the machine? They are using the machine for 5 hours. Okay, here they have paid $8. It means they are using it for 4 hours. Here it is $6. It means they are paying for 3 hours. Okay, so this is the concept here. So the machine hour per unit is a very important number because that is the limiting factor. So now you got the machine hours. So now you have to find out what is the contribution per machine hour. Okay, per machine hour, that you have to find. How will you find that? So this is $17 you get by the contribution from the product, but each product takes 5 hours. So per hour, how much you are actually you will get from producing this product is 3.4. This product you will get 2.75 per hour, and this one 4 you will get. Now you have to rank it. So whichever is the highest, you have to rank it first. This is first rank, second rank, and third rank. Okay, so you can put this as working note. You can put this as working note, and he's asking, you are required to determine the production plan that will determine the profit for the forthcoming period. Okay, so you have to tell what would be the products production plan. Okay, so production plan, we will just take it. So production plan, what is going to be, how many units we have to produce. Okay, see, first we have to produce G, then E, then F. Okay, so we can put it like this. First we can take it as particulars, then hours required, then hours available. Okay, so there are 3 products here. So E, F, and G. How many hours E will require? Okay, that we have to find out. So hours required, I think we'll put it here. E, we have to produce. Okay, see, they have not told how many hours. Okay, they have not told how many units that could be sold. No, they have given it. Okay, they have given it here. So you can sell E is 250, 140, and 130. But as per rank, okay, as per rank only you have to put. So as per rank, G becomes 1, E becomes 2, F becomes 3. So this is how you have to produce and sell. So how many hours it will require? So 130 units into how many hours it will take. I think we have found out G takes 3 hours. So this is 390. E takes 5 hours. And F takes 4 hours. Okay, so you can multiply that. So this is the total hours available. Okay, hours required. So we have to find out what's the hours available. Okay, so we can also produce units to be produced. We can also have that as a column. So The hours available at the initial is, he has said that 1400 hours is available. Okay, first we could give it to G. If we give it to G, we can produce 130 units, and if we give it to G, 1400 minus 390 hours will go. So the balance is now is what available. Okay, hours available now is only 1010. See, this 1010 hours, okay, has to be allocated next to E. So E has around 1250 hours required. See, so many hours we don't have. So F can never be produced, but E also cannot be like produced 250 units. We can only produce partially. So how many units we could produce? So maximum how much we have is uh, we have 1010 hours, and each unit of E takes 5 hours. So we can produce 202 units. Okay, we can produce 202 units. So available hours will actually become 0, right? The entire hours is gone. So here also available hours is gone. So this will be the production plan. Okay, you are required to determine the production plan that will maximize the profit for the forthcoming period. Okay, so the production plan is, the company should produce 130 units of G and 202 units of E. So that's about this problem. Hope you got an understanding. We'll move on to the next one. So if you want, I'll repeat it once so that you will get a good idea. So once you get this kind of a problem, limiting factor problem, and if it's going to be a single limiting factor problem, first set up a table to find out what is the contribution. So first find out the contribution, then thereafter find out what is the limiting factor. The limiting factor in the sum is the machine hour per unit. So first find out what is the machine hours per unit it is. Okay, so either it will be directly given in the sum sometimes, but sometimes it will be given indirectly. For example, in this sum it is indirect. So fixed production cost is absorbed at a rate of 2. So if you use this machine, you have to pay $2 per hour, and they have paid 10, 8 and 6 like that. So machine hour per unit comes to 10 of fixed production cost divided by 2 hours that we pay for every hour. So only 5 hours only we have used. Here 4 hours, here 3 hours. So we have put our machine hours. Thereafter we have to find out our contribution per machine hour. Okay, we have to find out that number. So if you find that number, okay, we'll little bit we'll okay, we can find out the contribution per unit. Thereafter, whichever is the highest, we will mark it as 1, the next as second and third. Then we have to find out the production plan. Production plan has to be as per the rank. So first we have to produce G, then E, then F. Okay, so that's how we have to produce. And if we produce in that manner, our these are our units, okay, or maximum demand. These are our maximum demand, and for what is the hours required for that maximum units, these are the hours required. How did we find it out? 130 units into how many hours each product will take. So this product will take, G will take 3 hours, E will take 5 hours, E takes 5 hours, and F takes 4 hours. Okay, thereafter we have to find out how to split. Total hours we have is 1400. We can easily produce 390 units, 390 hours we can easily produce G. So balance will be 1010. And how many units we could produce? We can produce 130 units. And for E, it requires 1250 hours, but we have only 1010 hours. So we cannot produce all of the 250 units. So how much we can produce is 1010 hours divided by how many hours it takes to produce 1E. It takes 5 machine hours. So 1010 divided by 5 gives you 202 units. So we have effectively used all the hours. So thereafter it is 0 only. Thereafter it is 0. So that's about the concept here. Our production plan is to produce G 130 units and E 202 units. F, we don't have sufficient hours to produce. Okay. So this is actually a short-term technique because next month, okay, or next quarter, the machine hours can increase or machine hours can also decrease. It can go in any manner. So this production plan is only valid till the hours available is going to be the limiting factor. Okay, so if this limiting factor hours is going to increase from 1400 to 2000, then we have 2000 hours available, so our production plan will change. Okay, so the current production plan is only for the current data that is given. When the data changes, the units to be produced and production plan will also change. So that's about this problem. We'll move on to the next problem. So this next problem is also a limiting factor problem, and we'll work out this problem and let's see how the answer works out. So we'll again we'll again start this with this problem. This is a very similar problem to what we have earlier done. Okay, and we can work it out. So we'll start from the requirement. Requirement is recommend a production mix that will maximize the profits of LMN Limited for the forthcoming period. Okay, so we have to tell a production mix which will increase the maximum profit. So he's not asking us to find out the maximum profit. He's asking only for the production mix. LMN has a valued customer to whom they wish to guarantee the supply of 50 units of each product next period. Would this alter your recommended production? Okay, so assume that we have a guaranteed supply to be given to a customer. Okay, and will this change? So which is the guaranteed product? We don't know. Of each product he asks. Okay, I think we will. Okay, I think we will work out in that manner also. Okay, it looks like different. So we'll start. So you can read this along here. Okay. So these two products are short in supply. These are the raw material for this company. These are short in supply. So as these are short in supply, they should be the limiting factor. But we have two products, two raw materials as limiting factor. The sum itself is named a single limiting factor. So how can we work it out? So just we'll see further information. So the company manufactures three products here: material A, B, and they have given maximum sales demand. They have also given maxi contribution per unit, that also they have given. So we first have to find out, okay, finding the limiting factor. Okay, first we find out the limiting factor. So how do we find out the limiting factor? We find out in this manner. So we'll first start with material A. So material A, if you see, there are three products here. So L, M and N. Okay, and we'll first find out, okay, material A per unit. So per unit, how much of material we want? We need 2, 1 and 4. And what's that maximum sales demand? So maximum sales demand is 120 units, 160 units, 110 units. Okay, so maximum material A required would be this much, and total, so total material A required is, add all the three, add all the three. So we need this much of kgs, we need 840, but total material A availability, so total material A availability, if you see it would be given somewhere. See, it's 1030 available. Okay, so these are in kgs. So you can see that required is 840 and available is 1030. Okay, hence material A is surplus. Okay, this is in surplus availability. So we have to work out the same for material B. So let's work it out. So material B, if you take, I think first we'll convert into everything into B. So material B required per unit is 5, 3 and 7, and maximum sales demand is same. Maximum required is going to be 600, 480 and 770. Okay, add all of them together, you get 1850 units kgs you require. Availability is only 1220. So this tells you that material B is limiting, is shortage. So whichever item is in shortage, that will become the limiting factor. So material B is the limiting factor, not material A. That's why, see, even though two materials have been given as limiting factor, only one of them will be the true limiting factor. Okay, so that's about how the problems are designed. So we have gone through that. We have to tell a production mix. Okay, so we have to tell the production mix. Of course, he has given us contribution per unit. He has given, and we also have to put a rank. See, okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, 118, 119, 1 So contribution per unit, he has says it's 15, 12, 17.5, and rank would be 1, 2, and 3. So rank is also given. So our next step is to get the production plan. So production plan, we'll take it from the previous sum. Okay, so the so we'll put it as material A required, then sorry, material B required, and material, okay, done. So material B required and available. Okay, so two things we have here. So first we'll see what's the maximum demand. Maximum demand is going to be in terms of, we have changed the order. The order is N, then L, then M. Okay, so the maximum demand is L is 120, M is 160, and N is 110. Okay, so this is the maximum demand. So let's get the material requirement. Material requirement, I think we have already done. So N requires 770 kg, L requires 600 kg. So we are getting it from here. And M requires 480 per kg. Okay, so the total availability of material is 1200 kg. So first we can give 1200 kg. From there we can give 770. Okay, if we give that, we will be ending up with a lower material. So still 450 material is available, but we can fully produce N. We can fully produce 110 units of N. Next, we require 450 kgs, but as we don't have 450 kgs, sorry, as we don't have 600 kgs, we can produce 450 kg of, use 450 kg of material B and produce L. L requires around, let's see how many kgs it requires. L requires 5 kg. Okay, 5 kg it requires. So this will become 0. This will become 0 because we have used all the material. And how many units we could produce? We could produce only 90 units. Okay, so we could produce only 90 units. So that's about this sum. And he says, in case the company wants to produce 50 units of each product, okay, 50 units of each product, then what would happen? So this is for A part of the question. Part A question's answer. Let's see for, let's see if it's going to be for B part. Okay, assume that we have to produce 50 of each, then our computation will change a little bit. Okay, it will change a little bit. How it will change is, so definitely we have to produce, we first have to produce 50 of each products, right? We have to produce 50, again 50, again 50. Thereafter we can produce how much ever we want. Okay, so let's see, to whom they wish to guarantee 50 of each in next plan, would this alter your recommended production plan? So maximum sales demand is this much of units. So first we can give it to these guys, right? We have to give it to these guys. Then we can sell to the external market. So in external market, we can't sell 110, 110 minus 50, balance 60 we could sell, and again 120 minus 50, 70 you can sell, and 160 minus 50, 110 we can sell. Okay, that's what we can sell. So first we have to sell these. We don't have any other option. Okay, and how much material they require, so we have to work out them. So okay, N requires 7 kg, L requires 5 kg, M requires 3 kg. So we can put it here also. So 50, so it is 60 units into 7 kg, 70 units into 5 kg, and 110 to 3 kg. Okay, so this is how we are going to sell it. So this is the material required. So first we have to allocate to all of these, right? So let's start. See, the units to be produced would see, let's see like how many we could produce. We can produce 350. 350 plus 250 is 600. 600 plus 150 is 750. So 750 plus 420 gives you 1170. Okay, so we can actually produce all these units. We can produce 50 of this, 50 of this, 50 of this, and even 50 of this. Okay, so if you want, we'll put it here. Okay, so up to here, how many kgs have gone? 1170 kgs is gone. So out of 1220, 1170 kg is gone. So what will be the material available? Material available will be 50 kgs are available. Okay, so after N is being produced, 50 kgs are available. This 50 kg could be given to produce L. Okay, 50 kg could be given to produce L. So how many kilograms L takes? It takes 5 kilograms per unit. So they could easily produce maximum 10 units. Okay, so look at the difference. The difference earlier it was 110 and 90 units, but now they could produce all these. Okay, all these they could produce, but there is a difference between the production plan. Okay, so when something is like compulsorily you have to give, then first you have to allocate to that, thereafter only you have to allocate for the other products. Okay, so that's about this sum. So we'll move on to the next one.